Somewhere in the American heartland, a factory processes one of the most powerful substances on Earth.
All credentials verified. Control. Gate is open. Proceeding to the unloading bay.
Uranium hexafluoride arrives as a solid. To move it, the facility heats each cylinder until the material becomes a gas.
The conversion process strips the fluorine away, leaving behind uranium dioxide, a pale yellow powder that becomes the fountain.
The pressure is fluctuating slightly on Station 4.
Noted. Continue monitoring the containment levels.
The milling process breaks down every large particle until the powder is perfectly uniform. Consistency at this stage determines everything that follows.
I'm adding the pressing aid now. Ensure the ventilation holds steady.
Confirmed. The flow rate is stable.
Every pellet begins as loose powder. The press will change that permanently.
These are called green pellets. Pressed, but not yet fired. At this stage, they are still fragile enough to crumble under pressure. The sintering furnace runs at over 1700 degrees Celsius. Inside, the green pellets will be permanently transformed. Sintering removes all the pressing aids and fuses the uranium dioxide into a dense ceramic.
Even after sintering,
Every pellet must be precision ground to exact tolerances. A difference of a fraction of a millimeter matters here.
Cracked surface here.
This batch looks good. Send it through.
Inspectors examine each pellet individually. Cracks, chips, or dimensional errors mean the pellet is pulled from the line. There is no tolerance for imperfection inside a reactor. The pellets need a container. These tubes, made from zircaloy alloy, are among the most precisely engineered components in the entire process. Loading is done with precision and patience. Each tube receives hundreds of pellets, stacked end to end in a perfect column 4 meters high.
Once loaded, each rod is sealed permanently. The end plugs are welded under a pressurized helium atmosphere to ensure a perfect hermetic seal.
Okay, this section looks good, all green.
Roger that. Let's move to the upper segment.
Every weld on every rod is tested ultrasonically. A single defect would compromise the rod in a reactor environment.
The individual rods do not stand alone. They must be assembled into fuel assemblies, each one a precise.
Ensure alignment before final insertion. Confirmed. The rod is secured in the grid. Rod by rod, the assembly takes shape. A structure that will eventually contain more than 264 individual.
All right, bring it down.
Watch the guide pins.
After days of precision work, the assembly stands complete. But before it can leave this facility, it must
confirm seating on the lower grids.
Lower grids confirmed, moving to the next phase.
Check the localized deviation at the 3-meter mark.
I see it. It's within tolerance, but let's flag it for review.
The laser scanner checks every dimension against design specifications. Tolerances are measured in hundredths of a millimeter.
Reference. The final inspection team reviews every square centimeter, any anomaly, any surface mark that doesn't conform to specification.
Lower slowly, keep it centered.
Approaching the collar, looking good, clear on the south side.
Set point reached. Confirm secure.
Each assembly is packed with the same care it was built with. These structures will not be touched again until they reach their destination.
Maintain current bearing. Watch the clearance.
Roger that, Supervisor. Moving to position.
Confirming torque on bracket 4.
Reaching target now. Verified. Noted.
Proceed to the next assembly.
Assemblies leave this facility under escort. Their destination is one of the country's operating nuclear power plants, where they will generate electricity for years.
And so the cycle continues. Powder becomes pellet, pellet becomes rod, rod becomes assembly.
Is how it is made. This is where it comes from. And this is the work that keeps the lights on.